something truly remarkable has been revealed by the James Webb Space Telescope. Light beams that appear to come from a bustling city but originate from a location light years away. This remarkable discovery has rekindled our interest in the possibility of extraterrestrial life. The telescope focused its attention on the closest exoplanet to our solar system, Proxima Centauri b, where mysterious, brilliant flashes of light were observed. These signals point to a sophisticated extraterrestrial civilization, tuned as we unravel the mystery. The concept of life beyond our planet has captivated scientists and the general public for centuries. The possibility of extraterrestrial life excites many people. However, the James Webb Space Telescope's discovery of clear signs that life might exist elsewhere in the universe marks a significant breakthrough. This remarkable telescope made an incredible discovery as it gazed out into the vastness of space. Detected lights on a faraway exoplanet that resembled the glow of alien cities, raising the intriguing possibility that this distant planet hosts a thriving metropolis. The scientific community is enthralled by this idea as it could be the monumental revelation they've been awaiting for a long time, that suggests that civilizations managed by intelligent beings exist in ways we are only beginning to imagine. Now, engineers from a distance of 4 light-years are wondering how long these city-like lights have been visible, patiently waiting for our technology to advance to the point where we could detect them. Columbia University astronomer David Kipping has described the planet where these lights were observed as intricate and one of a kind, due to its unusual interaction with its host star Proxima Centauri. This exoplanet behaves entirely differently from most rocky planets that absorb sunlight and emit energy as infrared radiation. The James Webb Space Telescope's crucial role in unraveling the universe's mysteries is highlighted by this remarkable discovery. Its capacity to capture infrared wavelengths was essential in determining the peculiar behavior of Proxima Centauri b, which is critical for understanding the planet's atmospheric conditions. Because of the significance of this finding, scientists have planned additional telescope-based investigations into the planet's atmosphere, hoping to determine whether it could support life. Thanks to the Webb Telescope's exceptional sensitivity to infrared light, we can observe Proxima Centauri b's behavior even during its night cycle. While many telescopes struggle to detect faint light in the vast blackness of space, the Webb Telescope excels at capturing even the tiniest flickers, making it the ideal instrument for determining whether the enigmatic city lights on the dark side of Proxima Centauri b are real. The telescope can detect space-based artificial light as long as it falls within a very narrow frequency range compared to that of regular stars. Proxima Centauri b's environment is profoundly affected by its dynamic relationship with its star. Like many other planets, it receives significant energy from Proxima Centauri. Similar to Earth, the planet experiences day and night cycles as it orbits its star. During the day, it endures intense heat, while at night it experiences significant cooling. Due to its unique composition, Proxima Centauri b undergoes large temperature swings. For instance, if the planet lacks an atmosphere, the daytime and nighttime temperatures could be extremely different, with one side scorching hot and the other freezing cold. Astronomers are particularly interested in this striking thermal variation because it provides valuable insights into the atmosphere of Proxima Centauri b. Thanks to the James Webb Space Telescope's ability to capture infrared images, scientists now have a better understanding of the planet's atmospheric properties and its thermal emissions. The Webb telescope plays a crucial role in these upcoming discoveries. Proxima Centauri b's orbital period coincides with the James Webb Telescope's orbit around Earth, allowing scientists to observe the planet's daylight cycles every 11.2 Earth days. The next logical step, assuming Proxima Centauri b has an atmosphere, is to examine its chemical composition to determine if it could support life. The presence of vital elements like oxygen, methane, and water vapor would indicate the possibility of life on the planet. This would necessitate investigating the intricate process of light passing through the planet's atmosphere. The James Webb Space Telescope excels at analyzing planetary atmospheres, though its primary function lies elsewhere. It is particularly effective at detecting concentrations of methane, carbon dioxide, and water vapor, but less effective at detecting free oxygen, essential indicator of biological activity. Still, the telescope can look for other important indicators like ozone, which suggests a healthy atmosphere capable of supporting life. The search for distant worlds progresses as researchers continue to analyze the data gathered by the Webb Space Telescope. This investigation brings us closer to answering one of humanity's most fundamental questions. Are we truly alone in the universe? It's essential to recognize that the James Webb Space Telescope can only observe a small number of exoplanets in close proximity to Earth. Astronomers will rely on ground-based observatories like the Extremely Large Telescope ELT, which will begin operations in 2028 to delve deeper into the study of planetary atmospheres. The ELT's objective is to provide clearer and more precise information on the possibility of life on distant exoplanets by conducting a more in-depth analysis of their atmospheric structures. In conclusion, researchers have ambitious plans for future space telescopes. They aim to develop technologies that reduce starlight interference to better observe the planets orbiting them. These future telescopes will focus on the faint light reflected by exoplanets, making it easier to analyze their atmospheres with greater clarity. It's akin to shielding your eyes from the sun to see more clearly. To evaluate their capacity to sustain life, however, is no easy task. It is difficult to detect the faint light that planets reflect because stars are so bright that they frequently overwhelm their neighboring planets, which is essential for examining their traits. Scientists are looking into many new ways to solve this problem. Coronagraphs, special devices installed inside telescopes to block starlight while allowing planet light to pass through, are one promising method. Coronagraphs can dim the star's brightness by carefully manipulating the light waves, making it easier to detect the dim light of exoplanets. The star shade, a massive flower-shaped spacecraft designed to fly in formation with a telescope tens of thousands of kilometers away, is another exciting approach. The star shade will prevent starlight from entering the telescope and ensure that the instruments only receive light from the exoplanet. Planets in the habitable zone of their stars, areas where liquid water and possibly life exist, may benefit especially from this method. However, these cutting-edge technologies call for exceptional precision. Over long distances, it is necessary to align a star shade to within millimeters, for instance. Furthermore, these innovations must overcome the challenges posed by space missions, such as the need for miniaturization, energy efficiency, and the ability to endure the harsh conditions of space. The potential rewards are immense despite these obstacles. Biosignatures, or chemical indicators of life such as oxygen, methane, or water vapor in particular, ratios could be discovered by successfully observing and analyzing the atmospheres of exoplanets. These molecules might point to the existence of biological processes, which would be convincing proof that life exists outside of Earth. Additionally, researchers are looking into methods for directly taking much more detailed images of faraway worlds. Advanced adaptive optics that adjust for distortions caused by Earth's atmosphere, or the telescope's movements, could be included in future telescopes, resulting in sharper images. These advancements have the potential to make it possible for scientists to not only locate exoplanets but also to map their surfaces and investigate their climates when they are paired with technologies that block starlight. In our quest to answer one of humanity's most fundamental questions, the development of next-generation space telescopes represents a significant advancement. Are we the only ones in the cosmos? Are getting closer to finding out if life exists beyond Earth by improving our ability to observe these faraway worlds. This could change how we see our place in the universe. Space exploration and the search for life beyond Earth are moving at a rate never before seen. The James Webb Space Telescope is ushering in a new era of cosmic discovery, allowing astronomers and scientists to delve deeper into the mysteries of distant exoplanets. Astronomers are using the information it collects to make groundbreaking discoveries about the structure, composition, and habitability of distant worlds. The ultimate question is getting closer to being answered with each new piece of information. Is there life elsewhere in the universe? The discovery of Proxima b and TRAPPIST-1 is only the beginning of what could be a significant turning point in our understanding of extraterrestrial life. Proxima Centauri, the star closest to our own solar system, has been the focus of extensive research for years. However, up until this point, it seemed like a distant dream to find tangible evidence of life, such as artificial light or signs of civilization. The Webb telescope's detection of such light only raises hopes that we will one day come into contact with other intelligent life forms in the universe. This kind of discovery inspires future generations to look beyond Earth's borders and peaks public interest as well as scientific curiosity. In addition to looking for artificial lights, the James Webb Space Telescope is also focusing on planets' atmospheres, their chemical composition, and the conditions that could support life as it continues its observations to determine whether these planets are capable of supporting life. It is essential to look for biomarkers, like methane or carbon dioxide, in the appropriate concentrations. The unique capability of the Webb telescope to examine these atmospheric components sheds light on the possibility that other distant worlds could support life similar to Earth's. Perhaps the most captivating aspect of this endeavor is the fact that we are observing the past, since it takes years for the light from these planets to reach us. What we see today actually happened years ago. Cosmic time machine transporting us back in time. Each discovery is a window into history. Humanity is on the verge of a new era. As the James Webb Space Telescope continues to collect data, an era where questions once deemed impossible, like the existence of alien civilizations, may finally be answered.